frequently. We see very teams that use static analyses effectively. We see some teams that don't use any analyses at all. And we see other teams that do use analyses, but they don't look at the results, or at least they don't take any measures out of that. And in that presentation, I want to show the analyses and the best practices we see in those teams, those few teams we know that use them effectively, to help you take away what you can do if you want to use analyses to have maintainable and long-living software. But before I start, if you have questions, please don't wait until the end of the talk. Just interrupt me and call in. Also, it doesn't need to be a well-articulated question. If you have doubts or think this is all stupid and we need to do it differently, just raise your hand and tell me. I said that I'm going to present our experiences, so some of our background, so that you can know where that comes from. We come from research. We did our PhD in program analysis and software engineering. And in the research time, we were mostly interested in what can you actually measure that makes sense. And 6 years ago, we founded a spin-off, the CQSE. We are 18 now. And in that period, we mostly learned what do you need to do to actually have an impact in practice. And so from that time, I want to share the experiences. Just to give you some background, we have some business information systems companies we work with, and we have a lot of embedded software. And while at first glance, a business information system, ABAP, is very different from an embedded control unit written in C or assembly, interestingly, on the long run, the challenges you have if you want to have maintainable software are very similar. So what I want to do now is first outline some analyses we think make sense, and then tell what you need to do to actually have an impact on your development from using those analyses. The first analysis I want to introduce is called clone detection. And I have here some ABAP code, and you see, although maybe you can't read that, it's pretty much the same on the left and on the right-hand side. And clone detection finds those copies that typically come from copy-paste programming. And just to get that out of the way, because we are in Munich, I'm not interested in plagiarism detection, although it's called copy-paste. Although you can use the same analyses to find plagiates, I'm interested in maintainability, because what we often see is if code is copy-pasted, if you need to make changes to one of the copies, the other copies are forgotten. As in this case, where a developer made a change here, which has not been made to the other areas. And that's something we very frequently see. And now, if you see that little bit of code next to each other, it's hard to feel why there should be a problem. And that's a problem of PowerPoint, because it trivializes that aspect a bit, because I don't get a lot of code on there. So I want to use a different visualization. I zoom out, and I now only use one single point per letter. You can't read the code anymore, but I get 5,000 lines of code onto that screen now. And if you look carefully, you can see from the indentation and the syntax highlighting that it's still code. And what I now do is I color code that has been copied in the same color. So this code is the same as that code. Same in the sense that it's identical, except maybe for comments or for white space or for formatting. And what I now do is I run our clone detection tool on this source code. And this system has been 3 years old at the time we analyzed that. So it's not something that has been evolved over decades and has been handed from team to team. And I get this picture, and if I zoom out, I get this picture. And I think now it's much easier to get an intuitive understanding that if you work in such a system, you often get a déjà vu. Whenever you change something here, or when you do a review here, you have the same review comments in the other areas that are pink. And I have another metaphor, how it feels like to work in such a system, namely memory. So you debug a problem, and you finally find the area of code where the problem is in, and you remember, I have seen that code someplace before, and no, here it's not. It's not. And then finally you find that. Thanks. And whenever we use metaphors in computer science, we need to know when the metaphor breaks. And now it breaks because in memory I know I'm done when I have found the second copy. I don't know that in source code. Although most clones are pairs, we have seen clones that are 5, 10. I think the record is at 80 times. So the most cloned area of manually maintained code we've seen has been copied 80 times. Maybe the developer who had to produce the 80th copy thought it has been copied 79 times already. I won't be the person who introduces the abstraction. So all of what I've told before up to now is anecdotes, but anecdotes is not data. So in my PhD, I wanted to know how grave is that problem in practice. And for that, I did a study with Munich Re, where we analyzed 3 C# systems, with LV 1871, where we analyzed a system written in COBOL, which was 17 years old at the time of the study, and an open source Java system to allow other researchers to replicate the study. And in that study, we focused on copies that had differences, like the one I had on the slide. Because just because I copy and modify it, it needs not be a problem. Sometimes I copy it and modify it because I need it to behave differently in my situation. So what I did in that year was I looked at several thousand clones that had those differences together with the developers of the system to answer if those differences are intentional or not, and if they are unintentional, if they are a bug or not. And we found more than 100 bugs, although the software system were in production at that time. And I think most interestingly, every second time a difference was unintentional, it was either a new bug or an existing bug that had been copied in many places and was not fixed in all the places. And maybe you know that sometimes when you do a change in a system, you write a comment with an issue tracker number. And what we sometimes see in systems is you have a clone and you have issue tracker numbers from 2 bugs that are 1 year apart, where the same fix has been done in the different places, and you can see in the issue tracker that it was a lot of effort, twice the debugging, twice the change management to get that fixed. So clone detection is one of the analysis we use, and we have a benchmark of several hundred systems, both industrial and open source, to have an estimate how much cloning is much. And the measure we use is clone coverage. So that is the probability if you take an arbitrary statement in the code, how likely is that covered by a clone? Or in other words, if you do a fix in one statement, how likely is that part of a copy of at least 15 statements in ABAP? And of a good young system, we expect less than 10%. Many of the systems we see, especially in ABAP, are way higher, like 30 or 40 or even 50%. And the record is 80%, but that's not a handwritten system, but something that was cross-compiled from COBOL to Java. And that was very copy-pasted in COBOL already, and it doesn't get better if you push that through a cross-compiler. So this concludes the slides on clone detection. We will demo a tool where you can see how clone detection works on ABAP in practice. A second analysis we work a lot with is architecture conformance analysis. The idea behind architecture conformance analysis is to see whether the implemented architecture matches the intended architecture. We don't analyze whether the architecture is good or bad, not because we don't want to know, but because that's something that an automated analysis cannot decide. That's simply not computable, because an architecture is good for something or bad for some scenario, but not good or bad in general. So what we do is we model the intended architecture with components, subcomponents, and policies. So whenever there's a green arrow between 2 components, the code in here may access or depend on the code in the other component. And this is a typical business information system with a UI, a business logic, and a persistency layer, and most of the dependencies go down. And what we now do is we extract all the dependencies from the code base and throw them against here. And then whenever there's a red arrow, there's a dependency in the code, which should not be there, at least according to the architecture. And for example, there's a red arrow here from the persistency up to the UI, and in that case, for example, there was a call to Excel to do some computation from the database layer. And that's not something you want, because then if you can only install that server on a machine that also runs Excel. We've also done studies there. Typically, a lot of the red arrows come from omissions in documentation. But I think the key point to take away is that those analyses are a very good basis for architecture discussions. Because often there's not one view of an intended architecture. Maybe there was one when there was a team of 2 and a very young system, but it evolves, and it evolves differently in every head. So I've presented clone detection, which we run in maybe 100 systems now, and architecture analysis, which we have maybe introduced in 60, 70 systems. And there's loads of other analyses. For example, code inspector, and there's other checks that search for structure, for guideline conformance, and so on. And now the naive hope we had when we built that during our research period was that you kind of put such a tool on a web page, and then some developer installs that, and then all the problems go away. And we analyzed that, and this is a chart where one system from January 2007 until January 11, and on this axis are the number of problems. So the number of clones plus the number of architecture violations and so on. And here we introduced our tool. So for a very short time, what you hoped for happens, namely that some problems get removed. Then at least it doesn't get worse, but then back to before. So no lasting impact. And that reminds me a lot of such a picture, where you, for some reason, buy a sports instrument and then hope everything gets well, but what really happens is this. If you look closely, there's a personal trainer here which doesn't appear to be in heavy use. And that's the same fate we see many analysis tools face in practice. And so the next part of the presentation, I want to talk about what you need to do not to end up in that situation with a static analysis tool. And the bad news is there's no one magical silver bullet. There's no one magical thing you need to do to have an effective use of a static analysis tool. There are many, and one we want to stress in the time we have is that you need to have a dedicated quality goal. What do I mean by that? If I run clone detection in such a system, it's not, or in any historically grown system, it's not unusual to have tens of thousands of findings of a tool. And what is the typical reaction? The analysis tool gets uninstalled because you have enough problems already. You don't want to see 20,000 new problems. Maybe management gets wind of that, and then you have all those escalation meetings and nobody benefits from those. Also, it's not a good idea, even if you had the time, to stop development and clean up all those 20,000 static analysis findings, because many of those are not critical per se, but are a problem for the long run. And you don't really know when you are going to change which code in the future. So, but uninstalling the tool doesn't help as well. So what, from our experience, helps is to differentiate between age of findings. So define a baseline, run the analysis, also run the analysis on the new code, and then see which problems are new. Because if you entered something last week, you still know the code. You don't need to reintroduce yourself with the code. And if you fix that, you don't need to retest. So it's pretty cheap to get rid of that. On the other hand, the stuff you inherited from an 8-year-old part of the system, you don't know the code, you need to re-assume yourself, you need to retest. It's much more expensive to fix that. And we go even further. We say we work with 4 dedicated quality goals, depending on how critical or how maintained the system areas are going to be. The trivial ones are I don't care, which means deinstalling the quality tool, and no deficits, which is like the trivial approach. You expect there to be 0 problems in your findings, which is only possible if you start on day 1. So what we typically use when we introduce a tool is no deficits, no new deficits. I compare against the baseline, and I only tackle the new stuff. The disadvantage is it never gets any better. So the third quality goal here is no deficits in change code, which is like the Boy Scout rule. If you touch a code for fixing a bug, at least clean up that scope, like that form or procedure or method. Because you are reaccustomed anyway, and you don't need to specifically to make that maintenance change. So the static, but this is not so easy, because if I get the information that there's a new problem or that there
findings perspective. We have also a dashboard perspective. Activity is like where you can follow what's going on in your development. Code, you can browse the code, and some more. Basically, one of the central perspectives is the findings perspective. It just lists all of your findings. In this small demo we had, it's the Open Checks project from GitHub. It's only a very small amount of findings, only 51, but in reality, as Elmar said, this could be a few thousands of findings. Now, let's start with, let's say we are interested in this, in the cloning, in the duplicated, and we want to see where is the longest clone and what it is about. We can, let's just filter to the clones. Only cloning selecting. Then we have the clones. Let's look for the longest one. And here we can inspect the clone. Here we get the part which is cloned. And of course, I'm interested in the sibling. And for that, we have a clone compare view, which is all running in the browser. So here we can clearly see that all of this class is duplicated. We see it by this blue marker here. But we see there are some differences. Some are in comments, okay, no. But of course, the class name is different, but all the remaining code is still the same. The only main difference between these two classes is this literal, which keyword is checked. Once is checked, one is exit. And all the rest is rather the same. In the end, there are still a few messages different. So this could give an indication to you. It would be an idea to add an additional base class to get rid of this duplication and do the maintenance only one. This was the part on clone detection, how clones are represented in Teamscale. Here, this was a clone of the whole class, or it's the same. Basically, a clone is everything which is longer than a certain sequence of statements. We've chosen here 15 statements. So it could be also a part of the file or of the object which is cloned. The next thing Elmar was talking about was the architecture conformance analysis. Here we have our own perspective, the architecture perspective. And it looks like this. We get here, we could define more architectures. But here's one, a very simple, very architecture, which is there, which looks like the images before in the slides. And here, basically, all dependencies are green, so everything is fine. But I have one big component here, which almost contains all of the system. And I want to split up this. There are the check classes in it and the parser, and I want to separate it. Let's do it how it works. It's a web-based editor for editing the architecture. It's quite easy. So delete this old component, and we add some new component, one specific for the checks, and one for the parser. So now I have empty components. There's no code associated. So this component is, you may add just your packages to a component, but you can map like across your system. You can map parts of packages to one component as you feel like. So we want to have all the check classes, which are starting with something AOC check, to the checks component. I can drag and drop one here, but in general, I added some regex, so to cover all check classes. And then I get not only check this one, but so all checks are gone from this list of remaining objects, and they're here. And now I see, oh, I have a dependency from checks to util. By default, this is not allowed, but of course, checks may use. I can look what it is. It's a structure. Yeah, I will allow this. So let's say let's put this to allowed. Now it's allow. So let's proceed with the parser. And we drop the parser class here, adding all of the parser. So yeah. So and of course we want also to allow this one. So there is one one object remaining, one class remaining. It's the super root class. And let's assume we want to get rid of this. So I put it in our own component, and I don't want this dependency anymore to this component. So I have here this component, and I leave it like it is. And now I save my architecture. Actually, I save it to some repository where it's versionized. And what happens then is that I can see hopefully a new finding, or new activity. This is the activity view of Teamscale, where we see what's going on. Oh, Teamscale has detected a change. And here I see my change made after the architecture modification. The same happens if you do a modification in your code. Then Teamscale detects it and shows you shortly after the change in your code. In the activity, we can see all the changes, and some have this marker with the red marker, and this indicates an additional finding. And again, if we go now to the findings perspective again, we see again all findings. We see now, if you noticed, before we had 51 findings, now it's 4 more. And I want to know what's more. Let's say here is the part of looking at the delta. I can show to some baseline. Let's say we have a baseline defined end of the last iteration. And what happens since then? Yeah, the 4 new architecture violations, because I have redefined my architecture. So now these are problems and I should resolve them. And also there is also one long method violation. It was introduced at September 4. Maybe we have a look at this. And what we also have now, we are back on this findings detail page we have seen from the colognes before. And what we can see here is also like, let's see the introduction diff. What changed in the system when this finding started? Oh yeah, here was a method, walk terminal. And it was pretty short before this change. But then with this change, there was this part of code inserted. So this was a violation of our method length threshold. And we have not, with the baseline function, we can select especially this new introduced finding. Finally, I want just to show you the dashboard perspective, which aggregates, which gives you a graphical overview of some quality indicators and stuff you're interested in your system. This is a tree map which shows the cloning. Each rectangular there is one of the objects, and these dark red ones are the longest clones we have seen before. So this is what I wanted to show you for Teamscale, for the demo. For the short demo, if you have more questions or want to see more details about Teamscale, we're around, so don't hesitate to ask us. And maybe we can also live analyze one of the GitHub projects. There is a connector. And one thing, these were GitHub projects, just because we don't want to show from our customer code. But of course, you can connect to your SAP server. That's it. Now, currently, we support ABAP Git projects which are exported with ABAP Git. Unfortunately, we don't support sublink nuggets or S-linkies so far.
It will be the sublink successor. ABAP Git is really a cool project. It's open source. It's the next generation of sublink. As a sublink maintainer. If you say this, then I believe it. It's really quick. It's really a Git client in ABAP. Okay. So that's everything.
Just the last slide. This was the chart we had before, and now we extended it to the right. And you see that at that point, we introduced the process we described with the quality goals, and where you clean up in the areas where you actually do changes anyway. And you see a more positive trend here. The number of problems goes down. And you also see that it goes down quickly at first, and then more slowly in the end, which is because this is a system where it only gets cleaned up in areas where the changes happen anyway. So the areas where a lot of maintenance takes place get cleaned pretty quickly, and then there are some problems that remain in areas of code that doesn't get touched anyway, and they're not problematic. Because we will give the slides to the organizers, and there's some links to additional material in case you want to dive into there. And you can download Teamscale or try it online. And as we said, we hand out free evaluation licenses, and it's free for open source use. To wrap up, tools are necessary for maintainable projects, but if we want to have enduring improvements, we need commitment from both developers and management, and it really only works if at least one person per team feels responsible. So there's no silver bullet on the tool side. We need somebody who feels responsible. Thanks for the time and interest. Any questions?
So what are the prerequisites? What ABAP version, NetWeaver version do you digest?
I think the oldest version we support is, what is this, ECC 650, or so every seven up system is fine. It's also some 6. What was the ECC, the last ECC version before NetWeaver 7? They will also support. I don't remember. 6. There's really no since the analysis part is done outside of the NetWeaver. So it's only the extraction part which is depends on the version.
Okay, so and I think as a company using Git is not so much common, especially not the bigger the company is. So do you have any interface not based on?
I think the commonality of Git depends on the programming languages. In other domains, it's pretty widespread, even in companies. So we do have Git interfaces. So especially in the Java and C# and C++ area, we work with companies that use Git. Yes, if you don't want to use Git, we just integrate into SAP.
Yeah. We just used Git in this demo because it's much easier to show a version history from a Git project, because instead of connecting it in a live demo to a NetWeaver instance. That was the only thing. But
yes. None of our SAP using customers uses Git. Further questions? Then thanks again.
So